are we all on this page? All right, so I'm going to show you something on Desmos, which is an absolute blessing. So if you have Desmos on your phone or on your computer, you got to go open. I want to make sure you know how to do this. This is another thing I'm going to show you on Desmos that you might get a little upset by your previous year's teachers. Why didn't they just show me this? It's so much easier. That's because I'm not dude. All right, so this is a relatively simple problem from Algebra 1. Basically, the first thing you'd have to do is you have to find the slope, and then you use something called point slope. And then from point slope, you could plug it in into slope intercept, or convert it to slope intercept to find the equation. But we're going to utilize the tools that are available for us to do it much nicer. So let's see, anything good here? Let's go Desmos. All right, so everyone is here. You feel comfortable? So we are going to plug in two data points. We're plugging in 2, 6, and we're plugging in -4, 3. Now this particular tool I'm showing you is really valuable when you have a lot of data that you're plugging in and you're trying to get some sort of regression model out of it. A regression model is the equation that would most closely fit your line of best fit. And this will be simple, but you're going to go and you hit the little plus button and you get to the table. Now you might have X1 and Y1 like I have, but mine are going to show up as green dots. Yours might show us as different dots, which is okay. We are on the graphing calculator page and looking at decimals. And your quiz is in, so check Schoology or Power School, you can see it. All right, so I'm going to plug in each point that I have. I have 2, 6. So there's my first point, and the dot shows up nicely. And then my other point is -4, 3. Oops. So everyone probably should be pretty good at realizing I have 2 individual points. Between 2 individual points, there's exactly 1 line that would connect those 2 points to each other. So what you're going to do is you need to use Desmos to do y = mx plus b. Okay, so this is what we're trying to get to. Okay, we're trying to get to that equation. Okay, now we're not there yet, but I want you to notice something about this equation. You guys know m is the slope, agree? B is the y-intercept. Good so far? And then I have x and y. But I want you to take a look at my x and y that I have above. My x and y above are x sub 1 and x and y sub 1. Agree? So the operating system for Desmos is pretty nice that it allows you to do stuff. So that's basically the equation we're heading towards. But I'm going to go x sub 1, or excuse me, y sub 1. And then I'm going to use the little tilde. Okay, now if you're using your phone, it might be harder to find tilde. So you kind of have to search for it. Yeah. If you just go Y1, it automatically does it for you. And if I look for tilde, if you don't have that, let's see, I wonder if it's under functions at all. Nope, it's not under that. So where you would find it is if you hit ABC, and then it's here at the very bottom where my finger is. Okay? So that little tilde down there, that little wavy line, the single wavy line, that's telling Desmos, oh, we need to figure out an equation. So I don't know what m is, so I'm going to say that. And we're going to call x sub 1, so x1, and then plus b. And once you do that, it's going, oops, hey, stop. Don't move stuff. Once you do that, it gives you basically the equation. It tells you the slope is 0.5, which is the same thing as 1/2. You can leave it as decimals, that's okay. And it gives you the y-intercept of 5, and then it gives you r squared, and it gives you r. So if any of you have taken a statistics class, that is the correlation. The correlation is r, and r, the closer it is to 1, the more exact your line of best fit will be as close to your points as possible. It's called the least squares regression model, which means you have a average distance, an average vertical distance from your points to the line of best fit. Okay? But our equation to this is just truly, if we change this to 0.5 and I change this to just 5, again, that's our line of best fit. That's our equation that works for our line. So you might come across something like that in future events that says, hey, and the nice thing is, if you tried the simple things on Desmos, you'll get good using Desmos for the little bit more complicated things that might take place in the future. Okay, so this says TI calculator. Friends, we're moving away from TI calculator because Desmos is something that is used so much more on standardized tests. And in the business world, a lot of times if you're sitting in a meeting, you might have to have your computer in front of you, and you could pull up Desmos pretty easily. And certainly there are other graphing programs, but Desmos is a nice free one that we can use. Okay, so if we looked at problem number 2, if I get rid of all this information and I look at problem number 2, I'm going to plot y equals, I don't have to do tilde, I'm just plugging the direct equation in, x raised to the 3rd. And one thing I want you to notice on Desmos, notice my cursor is still sitting at the exponent. So move it one spot over so it moves back down. Okay, I think some of you might have left on the test, you might have missed a problem because if you had an equation that it was raised to the x, you might have started typing beyond the x, and you might have had an exponent that had more than just numbers in it. Okay, so minus 2x raised to the 3rd, or the 2nd, arrow over, minus 6x minus 5. Okay, and what they want us to do on this, the directions say sketch the graph of the following function, label all key points such as the intercepts, the max and mins, and if there's any asymptotes. I'm going to take this back to home. So it looks like we have one x-intercept here. We have a y-intercept here. Actually, I got to bring this, make it a little bigger. Okay, so you're trying to see everything that's taking place. So here's my x-intercept. Here's my y-intercept. This is called a local max. Okay, meaning it's where our graph, so the algebra or the calculus terms you would use is this graph is increasing to the left of it. It's increasing, meaning that the slope of this line would be a positive slope. It gets up to this point where your slope is 0, and then it comes down this way, so it's decreasing down to here. If this is called the local max, friends, what do you think this would be called? Local min. And the nice thing is Desmos keeps everything up there for you. If you're using the TI graphing calculator, this is a lot more work to get the answer, bless you, on this particular problem. Okay, so this particular problem has a single real solution, meaning it's part of the real number system, meaning it crosses the x-axis one time. It does cross the y-axis. The y-axis is not a solution, it's just where it crosses the y-axis. It has a local maximum and it has a local minimum. Okay, so if I ask you what is the local maximum, you would give me the point that the local maximum is taking place at? If I said, what is just the max? And then if the next question after says, what is the local maximum? And then I said to you, what is the local max? You're going to give me the y value of that. And so in this case, our local max is negative 1.9. Okay, rounded to one decimal place. If I asked you for the local min, you give me the point, and then it says what is the local minimum value. Then you're going to give me y value, so negative 17.2 rounded to one decimal place. Okay, very straightforward, very easy. And if you're ever using Desmos and you have like zoomed in on some way away thing, you can always hit that little home that is on the far right, and it's going to take you back to zeroing it in between negative 10 to positive 10, then you can zoom your graph from that, which is really nice. Okay, and this is a live thing. It's going to stay there until you change it or until you log or you close out your program, which is also kind of cool. Okay, if we look at number 3, that's going to be y equals, and we have a fraction, so you're going to hit your little fraction key. Okay, so on the math on it, you can just hit the division button, and it's going to give you this as a fraction. So we have 3x on top, arrow down to the bottom, and x minus 2 on bottom. Okay, so this particular graph, if you kind of take a look at it, it crosses the x-axis right there. Okay, so that's where it crosses the x-axis. Okay, so that's the solution in the real number system. Again, the real number system is the name of the number system. It's called the real numbers. So other things that we're looking at. If you zoomed out on this graph a whole bunch, you're going to see it's going to go forever up, it's going to go forever down, it's going to go forever left, it's going to go forever right. But we actually have something called an asymptote. And an asymptote is something that you approach, but you don't get to. So on this particular problem, I'm going to do this. I need to go to this screen, actually go to the OneNote. So if I wanted to figure out the vertical asymptote, this is where the denominator, so the bottom, equals 0. So you take the bottom and you go x minus 2 equals 0, add 2 to both sides. So we have a vertical asymptote as x equals 2. X equals 2, if you remember this from Algebra 1, or maybe Algebra 2, a vertical asymptote is always x equals. The TI graphing calculator will not graph an x equals, Desmos will. So if I go back to Desmos on this and say, okay, what if I plot it x equals 2, that purple line is the vertical asymptote. Which means that the green line, as you go up forever, will get really, really, really close to it. And as I go down forever, it's going to get really, really close to it. Okay? It's an asymptote. We won't cross over. It won't ever equal it. It'll seem like it equals it as you go way up to, say, 300,000 in the y direction, and you click on the point. It's going to look like both the purple and the green, but it's just a really, really small decimal that it had gotten to. Now, in order to find the horizontal asymptote in the world of algebra, you're going to do this. Okay, so So if I want to find, I just said the wrong thing. If I want to find the horizontal asymptote, here's the rule. Top, bottom. Okay, numerator, denominator of a fraction, yes? If highest exponent on top is bigger than highest exponent on bottom, you don't have let me get rid of my annotations. You don't have a horizontal asymptote. Okay? If highest exponent is equal on top and bottom, so if you had x to the third on top and x to the third on bottom, that's the highest exponent. If they're equal, you're going to give me the lead number over the lead number. I'm going to explain what that means. So if I had 5x to the third on top, so I'm going to annotate again. So if I had 3x to the fifth over 10x to the fifth, and the equation kept going, you're going to take this lead coefficient over this one, so that means that y equals 3/10 is your horizontal asymptote. And then if your lead coefficient on bottom, so if the highest exponent's on bottom, or excuse me, yeah, on bottom, then y equals 0 will be that. So with that known, there's 3 different rules take place, and I have a whole lot of W left. So item 1, I have 3x on top, I have x minus 2 on bottom. The exponent on each of the x's would be what in this case? What's my highest exponent on top on that equation and on bottom? What's the exponent on 3x? 1. What's the highest exponent on bottom? Is the exponent on top the same as the exponent on bottom? So the exponents are equal. Agree? If the exponents are equal, the highest exponents are equal, I take the lead number, which is a 3 on top, over the lead number on bottom. The number on bottom is a 1. Okay? So that means that y equals 3 over 1, or y equals 3 is our horizontal asymptote. So if I go y equals 3 and graph it, that black line is now my horizontal asymptote, which means as I go forever to the left, my green line is going to get very, very close to 3 in the y direction. It's never going to cross, it's never going to touch it. As I go to the right, it's coming down, it's getting closer and closer and closer. It's squeezing very, very close to that horizontal asymptote. Okay, so this particular problem, if we were to look on OneNote, so we have the vertical asymptote, as we said, is x equals 2. We have the horizontal asymptote as y equals 3, okay, which is 3 over 1. And that's just taking place. I guess you could also, on Desmos, you could have done this. You could have said, well, where does it cross the y-axis? Well, it crosses the y-axis right there at 0. At 0, 0 is where it crosses. Okay, that can shift up and down. It doesn't always have to be there. So that's what's taking place. Okay, questions so far? Are we all right? Can I move to the next problem? So the next problem is an inequality, agree? So let's type it in as it sits, x squared minus 2x minus 15 And I'm just going to use the less than or equal to y. Okay? All right. So basically, if we type that in as it sits, I'm looking for where this would be below the x-axis. I'm going to actually flip this over and change this to y is greater than or equal to x squared minus 2x minus 15. It's going to give me the same one, which is great. I just flipped it over. Just verifying when you flip it over, it's going to come out the same. Okay. So I'm looking for where the y value, where the y value is greater than or equal to 0. All right. So I'm going to eliminate this first graph because there are too many things to look at. There's our equation. So now what we have to do is we have to talk about where is my double overlap of my shaded region? Is it above the x-axis? Is it below the x-axis? Do both the green and the blue intersect each other? The answer is yes, they intersect each other at this region here. So this region here, in between here, is where our solution is going to exist. So then we can create our domain. We're going to look to where our graph crosses the x-axis. And our domain is going to be this. Our domain is going to go from negative infinity, so forever to the left, all the way to -3. Our original equation had the equal sign underneath the inequality sign. So that means that the 3 is not a round bracket. Oops. It's going to be a square bracket. Okay? Because that dot is part of the equation. It's also equal at that point. And then my domain is going to go from square bracket 5 to infinity. So this means using the x to tell us what's going on in the y, the domain from negative infinity is this parabola is going to continue upward forever and ever and ever. And it's going to continue to go to the left, and it's going to continue to go to the right. So as I plug in a negative x value, that is to the left of 3, into our equation, means that my y value would give me a positive answer. If I plug a value that's bigger, or 5 or bigger, into our equation, it's going to give us a y value that is bigger than, it's going to be a positive number. So that's what we're doing, yeah. Okay, if you have a sign that is just this or this, you don't have a line underneath it, you know you're dealing with the soft brackets or the parentheses. If you have infinity, infinity always has a parenthesis, okay, because you can't get there. Yeah. But if you have a little minus underneath that way or this way, then you're going to use a square bracket for that particular number, not the infinities won't have a square bracket because I can't ever include infinity. I was just confused when I used those. Yeah, it's just basically it's when you have the little equal sign that's also part of the inequality. Thank you. All right, we doing good? Doing well? All right. So now they want us to talk about the domain of each of the other ones that are there. So I don't have y equals, which is fine. So I'm just going to go ahead and throw y equals. So I'm going to go the square root of x squared minus 16. And if you talk about what this domain of this particular problem would be, those are solid dots. Those will indeed work, meaning I will get square root of 0. Square root of 0 is 0. So my domain is going to go from negative infinity to negative 4 square bracket, and it's going to go from 4 square bracket to infinity. And we just have to note that if I take negative 4 and plug it in, or if I take 4 and plug it in, I'm going to get 16 minus 16, which is 0. Square root of 0 does indeed work. Sometimes you might have to watch out for these if the square root is in the denominator of a fraction. If it's in the denominator of a fraction, you know that the denominator of a fraction can't be equal to 0. And that might even be the next problem. Nope, it's just a wild one. Okay? So that's what our domain is there. That's really all that you have to list for that is negative infinity, negative 4, hard bracket at the 4, hard bracket 4 to also infinity. And then number 6, just plug it in. Let's get rid of this. It's nice that they always want to save it. I'll never come back to it. So y equals, make it as a fraction, x minus 3. Down arrow to x plus 1. Make sure everything stays downstairs. If it doesn't all stay upstairs or downstairs, you might want to put the top and bottom in parentheses. This does have a vertical and it has a horizontal asymptote, which is fine on this particular problem. Our vertical asymptote is where the bottom is equal to 0. What number can I plug in for x on the bottom that would make the whole thing 0? What plus 1 equals 0? Negative 1. So that's my vertical asymptote. So my domain of this one is going to go from, this line is going to continue this way. So our domain of this is negative infinity. And it's going to get very, very, very close to negative 1. I'm going to use a soft bracket there, okay, because I'm getting close to negative 1. It's an asymptote. I'm getting close to it. I want to cross it. And then my domain is going to go from negative 1 to infinity, which is this side of the graph, okay? That tells you that you have a soft bracket on both. That means that the point itself, negative 1, cannot work for this problem. I can get close to it from the left, and I can get close to it from the right. And when we start getting into limits, this actually doesn't have a limit because it goes to 2 different directions in the y direction. Am I losing anybody? All right. Last problem, and then we'll call it good. All right, that last problem, that is ugly. I have 4 minus x squared equals absolute value of x plus 2 minus 3. So I'm going to have the left and the right side that I have as y equals. So I'm going to go y equals 4 minus x squared and graph that, which is a parabola. That's great. And then I'm going to get y equals the absolute value. Absolute value is right here. And I'm going to get x plus 2. Arrow over. Nope, that's not going to work. And then hit the absolute value one more time. And then minus 3. So if we're looking for where these graphs intersect each other, zoom in on it. Just click on the 2 points that work. Okay. Being the graph does not have a y originally, you're only looking at the x values of the points. So the negative 2.5 and the 1.8 rounded to 1 decimal would be our answer. So we're only looking at the x values on because the original problem didn't have y equals. What we did is we utilized Desmos to try and take care of it for us. If you try typing that into Desmos, I don't know if it's going to work for you very well, other than taking the left side, make it at y equals the left side, y equals the right side, and it goes from there. All right. So, are we good? So I feel that this here, if you go on to Graphing Review 1, let's make this due Tuesday, the front and back. Does that make sense? Because tomorrow is Friday. So tomorrow we are going to build upon the taxes. I'm going to show you two things that go with taxes. There's one that's called the standard deduction. And the other thing is, what else can you take away from your taxes to make your taxable income less, so you actually pay the federal government less in taxes, and that'll help you on that. Cool? Just throw